I'm excited to talk with you all about my journey at Google working on upgrading 3,000 proxies. Let's jump right into this. So everyone knows that Istio is a security-focused product, that one of the key motivations for adoption of Istio is security. Yesterday, we heard from Eric Brewer about how Istio enables zero trust with features like MTLS, certificate rotation, and auth policies. But there's a bit of an asterisk about Istio making your service mesh more secure. And that is that 88% of Istio installations in the wild are running known critical vulnerability exploits. So what does it mean to be running a known CVE? This means that you're either not running the latest patch version. So Istio's been notified of a vulnerability. We've released a patch. We've let everyone know about it, but it's not been picked up. So if you've not installed the latest patch release, you're vulnerable. Additionally, it could be installations that are running old minor versions that are actually no longer supported by the Istio community and are therefore no longer receiving security patches. So when new vulnerability reports come in, we know that, say, Istio 1.6 is vulnerable to a number of attacks, but because we're no longer supporting that release, we're not releasing patches to patch those vulnerabilities anymore, making our users, if you're running a 1.6 version of raw or of open source Istio, you are vulnerable. So this is something that concerns the Istio community a lot, that the user experience working group and the environments working group and others have spent a lot of time thinking about. So today we are going to start by looking at why our users aren't upgrading, why that 88% number. It seems very large. I'm going to share my personal story of how I upgraded 3,000 proxies in my sleep, and then we'll cover some ways that you can do the same using purely open source technology. And then we'll turn to our takeaways. Also, as we get started, I want to give a little bit of a warning on terminology. We in the Istio project use the terms proxy, sidecar, and data plane pretty much interchangeably. We're referring to the Envoy sidecar proxy that sits inside the pod and is provided by Istio. Those are mostly the same thing that we're referring to, certainly will be the same thing in this talk, but the architecture should not be overwhelming to you. All you need to know in this talk as far as architecture is that Istio is divided into a control plane, which you run one of, and a data plane that consists of one proxy per pod in your service mesh. If you understand that basic divide, that you've got proxies and you've got a control plane telling them what to do, you'll be able to follow this talk just fine. It's also worth noting that the proxy exists because the control plane schedules it. A new pod starts up in your service mesh, and Kubernetes will ask the control plane, hey, what proxy should this run? And the control plane will do what's called sidecar injection. All right, with that, let's jump into why our users are not upgrading. We've gone through a number of theories about why our users aren't staying up to date through the years. Back in Q2 2020, we saw that many users were running vulnerable versions, and our hypothesis was that the users weren't aware that those versions were vulnerable. So in Q3, we launched an upgrade survey asking users which versions they ran and whether they thought that they were vulnerable. And what we learned was surprising. There were some users who weren't aware of the vulnerabilities that they had in their service mesh, but there was a much larger number of users who were aware that they really needed to upgrade their service mesh, but they kept telling us, I just don't have time. It's too much work. I'm not able to get to it right now. So in Q4 2020, we kicked off some work around making upgrades easier. Our theory was that upgrades are too difficult and dangerous, and so users simply don't have the time to upgrade their service mesh. Our roadmap for 2021 and continuing on into 2022, as you'll see tomorrow at the roadmap review, focused heavily on day two operations, very heavily on easing upgrades, making it simple, making it safe, making it easy to do. And we heard back from users in our survey results, as we covered yesterday at the keynote, that this is working. Our upgrades are definitely getting easier for users. But still, that number, 88% of running Istio installations are vulnerable, it didn't actually move much. So Q2 of 2021, we came up with a new hypothesis. Maybe we're asking users to upgrade too frequently, right? Everyone knows in order to keep your Istio installation up to date, you not only have to install patches as they come out about once a month, but you also need to do a minor version upgrade about once a quarter. And usually there's a lot of testing that goes along with this to make sure that everything in your Istio installation is still working. So what if we could do that only twice a year? Well, in Q3, we rolled out reduced upgrade cadence. This means that you can now upgrade your directly from, say, version 111 to 113. And because our releases come out once a quarter, that means you have the ability to upgrade only 2 times a year across minor versions, cutting your toil in half. So we've had a lot of work to get users to upgrade over the last 2 years. But the bottom line is we haven't actually moved the needle much in terms of what's actually running in Istio in the wild. So this year, we've come up with a new hypothesis. It's pretty controversial. I know that a lot of you are going to disagree, but I think, and we think at Istio, that humans are bad at monotonous, repetitive labor. I know it's groundbreaking and shocking, but really, if we look at what we're asking our users to do, once a month, our users have to get in the habit of checking for a patch release, of rolling it out. At least twice a year, our users have to get into the habit of scheduling their minor version upgrade. They only have a 6-week window to do it, so they've got to make sure that their schedule is clear during that time. They do all the appropriate testing. If they find any bugs, they've got to find a way to mitigate them or to work with the Istio community to get them resolved in a patch release. There is a lot of monotonous, repetitive labor involved in rolling Istio out. And so in this talk, we're going to try to take a chunk out of that, see what we can do to improve that. And of course, at Google, we solve problems the Google way, which generally involves building a managed service. You've heard of GKE, Google Kubernetes Engine, which is managed Kubernetes service. At Google, we launched Anthos Service Mesh, which is a managed version of Istio. Let's take a deep dive into how we launched a managed service to control Istio and how that helped with this monotonous repetitive labor. Everyone knows that the control plane of Istio is called Istio-D, and Google simply moved it into a managed service that we call Anthos Service Mesh. So rather than having your Envoy proxy connect directly to a local version of the control plane in the cluster, it calls this googleapis.com URI, which allows us to use our internal config as code and continuous deployment systems to keep your control plane constantly up to date. So as a managed ASM user, you don't even know when your control plane upgrades. It's pretty great. You don't need to think about it. But is that fully managed in terms of utilizing Istio? Really, we've only talked about the control plane so far, and what managed means for a sidecar is a little bit more abstract, because the sidecar, as we mentioned, will run inside your pods. We're not going to run it as a Google 3 service anytime soon. It needs to sit in very close proximity to the workloads that it's proxying. So what could we do to provide the same managed experience where things get upgraded automatically and you don't have to think about it, but for a sidecar that runs inside your application's pods? Well, for this, we really boiled it down to managed doesn't necessarily mean it runs at Google. It means that our users don't have to think about it, that it just works and it keeps itself up to date. And so we launched the managed data plane for Anthos Service Mesh, and it works very much similarly to the way that our control plane works. We still have the googleapis.com URL for Envoy to get control plane information. But in addition to that, we have our config as code and CD systems internal to Google writing a declarative proxy version into your cluster. And then we have a local controller in the cluster. And it's super simple. All it does is look to see, are the envoys running at the version that has been declared? If not, evict them. When an envoy gets evicted, a pod controller like deployment, say, should schedule a new pod, and that new pod will talk to googleapis.com and get the new version of the proxy that we want. Architecturally, it's very simple. Behind the scenes on the Google side, there's all sorts of additional complexity to make sure that if you have a multi-regional deployment of Kubernetes, or if you have multiple clusters, that we're not rolling out to 2 of them at the same time to ensure high availability. But the concept overall is pretty simple. Let's see how this worked in a recent rollout at Google. This was for a CVE that we announced at the end of February, and we went ahead and patched it for all of our users. The chart shows the progress in the data plane of a rollout. Remember, we don't want to roll too quickly. We want to make sure to go slowly. these proxies are handling all of your network traffic. And so by moving slowly, we should ensure that we catch problems early and roll back before we cause any problems. In this case, we didn't need to roll back. There were no problems with the rollout. And you can see that over the course of several weeks, we slowly moved from 0 to 100% in the rollout. Now, I know that I said at the beginning that I upgraded 3,000 proxies in my sleep, and I do have to confess that that was a bit of a lie. The rollout took 3 weeks, so I did a few other things. Um, I'm a big fan of mountain biking, and my lawn here in Seattle, Washington grows insanely fast this time of year, so I probably had to mow it about 3 times during the rollout. But the point is, this was a rollout that I didn't have to think about. It went smoothly because it was automated. I could trust it because of the automation tools that we had in place. Now, I promised that we would talk about how you can upgrade 3,000 proxies in your sleep or on a bike or a lawnmower or doing your hobby of choice. So let's take a look at what it would take to bring this magic from inside the Google ecosystem and make it accessible via open source. What we need is a way to define all of our service mesh's state in source control, just like that config as code system that we mentioned at Google. Once it's in source control, rolling back a change is as easy as a pull request. So can we invent a system that does this, that moves our Kubernetes code from a source control system into our cluster automatically? Well, it turns out we don't need to invent this from scratch. Just last fall, the GitOps Principles V1 were published. And in particular, what we've talked about is we need our service mesh state to be declarative so that nothing happens incidentally or by surprise. All of the config controls all of the state of the service mesh. And it needs to be able to be versioned so that we can roll back. There's other principles like pulled automatically and continuously reconciled. These are also important to us, but if you want to deep dive into what these principles mean, I've got a link at the bottom of your screen where you can learn more. So we need GitOps tooling for IstioD. Well, it just so happens that we also didn't have to invent that for scratch. The folks at Weaveworks, Stefan Prodan in particular, have launched GitOps Istio, which is an existing tool that serves as a reference architecture for how you can not only use Istio to perform GitOps with things like progressive delivery and Flagger, but also how you can use GitOps to manage Istio. So they've got this nice diagram here on how this works. You push a change into Git, and a tool called Flux picks it up and applies it to Kubernetes. This includes your Istio operator, which spins up IstioD, your gateways, Prometheus, anything you need. In addition to that, at the top of the diagram, you can see that we have GitHub Actions are automatically and on a regular basis checking for new versions of Istio and in making sure that the control plane stays up to date. I'm also happy to share that we've worked with Weaveworks to move this platform onto our newly launched GitHub action called Get Istio Control. This is in pre-release right now. You can find it in the GitHub Marketplace. It's super simple. You provide it with a semantic version range, like I want a 1.12.star version of Istio Control, meaning I want the latest 1.12, and it will get that for you in your GitHub Actions environment for you then to run whatever Istio Control commands you would like to run within GitOps. This is a brand new launch, just came out last week at v0.1. It's early days, but I would really love your feedback. If you kick the tires on this, let me know what you think. All right, so let's demo how this process works. We have here a pretty ordinary cluster. I've already installed the Istio GitOps demo. I'm staying at a pretty high level here because we don't have enough time to dive deep on all of this, but you saw the URL to the repo earlier, and I'll repeat it later so that you can dig into the details yourself. And you can see that we are running pilot, also known as IstioD, at version 1.12.1 in our cluster. And we want to change that. So let's go ahead and go over to our Git repo. Great. So look at this. Our automatic action has created a pull request for us. You can check it out on the Actions tab. By the way, I'm running this demo from my own fork of Stefan's because I didn't have time to merge everything back in this morning as I was madly fixing bugs. It's supposed to be merged in within the next week. Let's take a look at this pull request. We want to update Istio to 1.13.3 is our latest version. That's great. Let's see what this change looks like. And sure enough, we're going from 1.12.1 to 1.13.3, and there's some changes to Prometheus that are involved in the charts there. Those look like things that I'm not necessarily going to cover right here. Additionally, what's pretty cool is we have some automated checks set up. Uh, we ran an end-to-end test, which spun up a kind cluster, Kubernetes in Docker, installed all of Istio, all of our application, the front end, the back end, and ran a few tests on it to make sure that everything worked. We also were able to run analyze Istio, the Istio control analyze checks, which tell us if we've made any mistakes in our Istio config itself, and all of these checks have passed. So now that we have high confidence, let's go ahead and squash and merge this. Now it is going to take a couple of minutes for this to make it into our cluster, so I'm going to move back to our demo for now. We'll double back to check on that version of the control plane a little bit later. Pardon me as I get our presentation back online here. Okay. So advantages and disadvantages of this system. Our control plane has been maintained with, and it's up to date within any semver range that we specify. If we want to stay on 112 star, it'll install all the 112 patches as they come out, but it won't upgrade to 113. In this case, we've just said, give me whatever the latest is. So we just upgraded from 112.1 to 113.3. And each of those updates gives us a pull request. So we have an opportunity to review the changes that are going out to our cluster before they get there. And we have full testing with kind in our E2E test suite. So we have pretty good deal of confidence that the test is exact, or that the change is exactly what we want to see. But we didn't do anything to control our proxies. If we changed nothing, what would happen now is any pods that happen to restart would get the new version of the proxy, and any pods that happen to not restart would stay on the old version. And there are a couple of known CVEs in the 112.1 release that we aren't necessarily comfortable with running. So we need to make sure that those get updated. Normally at this point, you would need to log into your production cluster and start running rollout restarts. That wouldn't be great. We want to make sure that our entire state is defined in Git. So we're going to tackle that in a minute. Also, we would like to run this out of Helm instead of the Istio operator and use fully revision-based upgrades. These are best practices for your Istio install that we haven't had time to roll out into this repository yet, but we intend to over the coming months. Let's take a look at the problem of proxies. Proxies are defined imperatively in Istio. If you think of the software development lifecycle from build to test to release to deploy to operate, the proxy is defined at the operation phase, right? If any of our deployments happens to scale up right now, what will happen is they will get the new proxies, but the older pods that were existed before the scale up won't get the new proxy. That's really not a great place. Really, in order to have a declarative API, you have to happen at or before the deploy phase. In addition, we really would like to have our test phase be mimicking production. The fact that our proxy isn't defined all the way until operate in production means what we tested may or may not match up with what we're actually rolling out to our users. Let's see what we can do to improve this. Let's see if we can move the GitOps definition of our proxy right into the test phase so that from there forward, we have a consistent version of the proxy accompanying our application. It also means that our proxy upgrades will roll out according to application rules. Weaveworks has this great tool called Flagger, built on top of Istio, that progressively shifts traffic from one version of an app to the next. And it can go as slow as you want, say 10% of traffic to the new version for 2 hours before moving forward. And we can take advantage of that with our proxy rollout as well by moving to a GitOps model. Also, our rollbacks of not only the control plane, but also the data plane become as simple as a git revert. So how do you define your sidecar in Git? There's been a command known as Istio control cube inject, part of the project for many years now, and it mimics the logic of the sidecar injector on your YAML file. So we're going to disable sidecar injection and run cube inject from within GitHub Actions. so that your kube inject will take a deployment.yaml file as an input. It'll add a sidecar to it, and then we're going to have to write that as deployment.gen.yaml. Let's take a look at what workflow this will be. So a new version of Istio comes out. We write that new control plane YAML into Git, which we already saw, and it has the pull request with kind tests, an approval process before the commit, in which case it gets deployed to Kubernetes. Then we have a second GitHub action that is going to check and say, hey, what version of the control plane are you running? And does the proxy version match that? In this case, it's going to say, no, you're on proxy version 112.1. Your control plane is 112.3 or 113.3. So we're going to create a new pull request, updating your proxy to 113.3. It's going to go through the same kind test, the same analyze step, require the same approvers. And once it's committed, it'll deploy to Kubernetes in exactly the same way. All right, let's check out the demo. All right, before we kick off that demo, let's check back in on our control plane to make sure that it's rolled out properly. Remember, we had 112.1 before, and now we see version 113.3 of pilot. And that was all done automatically just as a result of merging a pull request. So that's pretty cool. If we look at our data plane version for one of our applications, this is the front end application, we can see the data plane still on 112.1. So let's see what we can do about that. We're going to come in here to the pull requests tab, and look at that. A new pull request has appeared. Oh, by the way, it looks like our tests have failed here, and that is actually not an intended part of the demo. So ordinarily, I would not merge this pull request. I would dig into the end-to-end test to understand why it's failing using this details link here. Since that's not an intended part of the demo, I'm not going to open that can of worms at the moment. But we can look at what's changed in our repo, and we can see in this deployment.gen.yaml file, we went from proxy version 112.1 to proxy version 113.3. And we did that in a number of places across our Git code base. So I'm going to pretend that this check passed. We're going to go ahead and squash and merge and hope that the failure is not something that breaks our demo. Don't do this in production, people. All right. And this time we are going to kind of wait and watch for the new version of the proxy to roll out. It'll take just a few minutes here. In the meantime, oh, nope, I can't do that in the meantime. Still on 112.1. I'm going to go ahead and start talking about some of the advantages of this model and the disadvantages. So the advantages here are our proxy version is completely defined inside Git. Our proxies don't upgrade until we approve the pull request. There's no implicit, oh, the control plane upgraded, so now surprise, you got a new version of the proxy. Another advantage is that because we're using the deployment to contain our proxy, Flagger can pick up the change to the deployment and progressively shift traffic from version 112.1 of the deployment to version 113.3. I'm not seeing this get picked up, which of course is always the risk with a live demo. Our pull request did merge. We'll run a quick troubleshooting command. Status is ready, and we got 1C57 picked up. This went in as 1C57, so we really ought to be seeing a 113.3 image get reconciled. Oh, there it is. All right. I survived the live demo. Our proxy has now rolled out. Incidentally, it's not done with the rollout because it's hit the deployment that Flagger is controlling. Flagger is going to slowly, over the next hour, shift our traffic over to this version of the proxy, but I won't make you sit around and wait to watch that. All right, so let's talk about what we just saw. Again, it's going to take me a minute to set this up. speaker notes. Move those over here. Bring this back to full screen. Thanks for your patience. So we've talked about the advantages and the automated, we didn't talk about that Flagger, if it detects any problems in the new version of the proxy, will automatically fail back to 112.1 and will open a pull request to roll, excuse me, we'll open a pull request to roll our Git repository back to 112.1 so that it shows the current state of the cluster. We've still got some disadvantages. That gen.yaml file adds lots of noise to workload YAMLs. As a matter of fact, if you're modifying your workload, the pull request process is double. You modify the workload YAML, you submit it, then the GitHub action picks that up and creates a new pull request to roll that out. It's not ideal. Also, we're not respecting revisions. We talked a little bit about that earlier. And rollouts to multiple clusters still have to be manually coordinated. All of that amazing Google infrastructure around ensuring that two clusters in a multi-cluster installation don't get upgraded at the same time is still something that we need to add in the open source ecosystem. In the future, we'd like our workflow to look something like this. When a new version of Istio becomes available, we roll out, instead of upgrading the control plane, we release a new revision of the control plane in our cluster. If you've ever used revision-based updates, this new revision is going to do nothing until we start adjusting some of the tags in our cluster. So we're going to first roll it out through the pull request process, deploy to Kubernetes, and then we can say, hey, we've got a tag called maybe Istio Rapid. Let's go ahead and move all of our Rapid stuff onto this new revision of the control plane. That tag will be defined in Git as well. So it'll go through the regular pull request process. And once it's committed, we can do the same thing, or during the commit, we can do the same thing in terms of proxy injection. If this pod is mapped to using tags to a particular revision, we'll make sure it gets injected with that exact revision version of the data plane. Then the only thing we have left to do is to clean up our unused revisions. Once we've migrated all of our tags to a new version, there will be a cleanup step that happens as well. This is what we're iterating towards. We hope we can get there within a few months. But in the meantime, we'd love to hear what you think of this reference architecture for upgrading Istio with GitOps. If you take away only one thing from this presentation, I hope it is that you need a plan for keeping Istio up to date. You should not leave your critical security infrastructure just unmanaged. So there are a few ways to do that. You can invest in GitOps to automate your Istio upgrades. And I would love to hear, if you do that, how our reference architecture either helped or hindered you in that process. You can also pay a vendor to upgrade Istio. As I mentioned, managed ASM customers don't need to think about upgrades. Or you could budget about one engineer to keep Istio up to date. One engineer is an average. It really depends on the size of your installation. We've talked to customers. Actually, we just heard from Splunk yesterday that their entire team spends 60% of their time keeping Istio up to date. That's a lot of time. We wish it didn't take that much. I'd like to see how automation can improve that, but I would rather see you invest an entire team in keeping Istio up to date than run vulnerable software in production. Also, there's some related resources available as a part of the conference. Today at 11 o'clock Pacific, we have our upgrade listening session. We would love to hear from you how we're doing on upgrades, what we can be doing better, what areas need improvement, and whether our new hypothesis resonates with you for how to improve the upgrade situation. We also have a workshop that will make use of managed ASM tomorrow at 11 o'clock Pacific. So if you'd like to kick the tires on that, please sign up in advance so that we can get you added and get a Google Cloud project set up for you. We're also going to hear tomorrow at 11:30 Pacific from my friend Rahul at WP Engine on how they've used ASM and how that's paved the way to success for them. Additionally, if you'd like to chat with our team about how managed ASM can help you, you can click the link there and fill out a form, and we'll spend 30 minutes talking to you. That is all. You can find all of the code from this demo at the link below and soon at the main repo that is owned by Stefan Prodden. Thank you for your time, IstioCon.